Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so what do we have? Notifications. Radar does not render water. This bug occurs. It was possibly introduced in the main branch. Skirmish. I have a suspicion what it was caused by. Water. There was a water change somewhere, yeah. From Thompson's. Thompson's. Here, this one. Perhaps introduced by that. Okay, what about this guy? It would seem that VC6 doesn't like the helper templates. Figured out VC6 doesn't support Pragma once. Huh? It does. It does. Wasn't that? So what does this change to? Hold on. So it complains template class has already been defined as a non-template class. As a non-template. That's weird. This is using partial template class specialization. Perhaps VC6 does not support that. It's partial, yeah, because this type is not. This type is still a template type. So, and only this is specialized, the two here. Yeah. It's using partial. It's using what is called partial template class specialization. Let me ask ChatGPT. Does VC6 support partial template class specialization? No. VC6 does support full class template specialization. It lacks support for partial specialization. Okay. me copy this here. Copy. Chat. GPT says would you like a workaround? Workarounds? Yes. Here's a workaround. Using helper structs in full specialization. Simulate this partial specialization which VC6 does not support. Class. Specialized for second type being int. Workaround using helper class. Let me append this. Let me remove this. Hold on. So class, wrapper class, full specialization, primary not specialized. Specialized. Full specialization, yeah. Simulates this partial specialization, which VC6 does not support. Workarounds. My class imp tu t int. How is that a full specialization? We have a partial specialization here. Huh? I don't understand. Wrapper class. Push the specialization into a secondary template and call it from the main class. Okay. Well, let Mauler deal with it. But yeah, I guess it's worth a try to do this here. There. Good. Let me. I guess we can merge this guy, right? True. On second thought, I think you're. I suggest leave the original comments and revert them. Revert them instead. Can leave that blank line here. I think this change needs tests in multiplayer because this was originally this is where originally the incompatibility was reported. Multiplayer with AI, because this is where originally the was reported. Fixed loop index comparison warnings. Fix an issue where drawer points to an invalid address instead of update due to being destroyed and recreated. Only occurs when the memory manager is off. Fix memory exception of drawable. There was a similar fix recently. Bomb truck. comes from Molar. This one, all right. Draw, get object, get drawable, obtain the new drawable. Draw, get object. Change visual disguise. Change visual disguise. Oof. What is this doing? Change visual disguise. Remove object. Add object. Draw. Draw. New drawable. I see. I see. That is really tricky. This one changes the drawable. Oof. Are there maybe more of these calls? So there's this call here, draw, restore hidden state, yeah. Yeah, it looks safe, yeah. So I think we can give it the same labels as this one here. Fix, memory, minor, stability. Fix, memory, minor, stability. It's sad because it's sneaky. Yeah. Yeah. I don't have a better. No, it's easy to shoot yourself in the foot. Right? You call this function, and then if you have a local pointer to the drawable, it now is dangling. Right? I mean, that's not a good way to defend here. With the way this is built. Well, you could have like a function get drawable that's part of step update, and you always call this instead of caching it in draw. You could do that, I guess. Yeah. Good. Then let's add the review approve. Fix memory exception of drawable when bomb truck. Fix memory exception. Fix. This should be fix. I don't like the title. It's not good. The title should be fix dangling draw. Fix dangling pointer in this function. When Chile bomb truck disguises, changes disguise. Fix dangling pointer and step update when Chile bomb truck changes disguise. I think that's a better description. Only this is a problem when the game memory manager is turned off. Fix this issue where draw points to an invalid address. This does not fix an issue. This only is a problem when the game memory manager is turned off. It is not a problem. It is not a. It does not. It. This can cause crashing when the game memory manager is turned off. It does not cause crashing in retail game with the game memory manager. To do does not cause crashing in retail game. There we go. Fix dangling pointer. There we go. Good. So this one is merged. Fantastic. Refresh. So let's see. I've not used it before myself. Just looking it up. It's possibly not working due to a defect. Not supported with the way it has been implemented. Okay. I think we can also merge this guy here. Okay, delete. Okay, and I think we can prepare the next change. Or fix mismatch and release build. Or let's say let's look at this issue again here that we were working on in a previous session. So we were trying to trim unreachable instructions in the unassemblize tool. I think one issue is that I was just thinking about it today. One issue here is that the indexer here is wrong, right? So the bit array is allocated for the jump count, but here we take an index of the instruction. So that's not right. How do we know? fixed. I think the easiest here is we simply do I think what we do is I think we can do we allocate it by the instruction counts. And then we can remove this guy. And we can rename this here. We say jump taken bits. Jump not taken, or jumps not taken, jump not taken. Jump taken. And then we do jump taken. We use that guy here. Unconditional jump taken here. Jump not taken. Okay, so that should already fix an issue. Yeah, we had. Can do instruction count. Pass that here. Let's see. There's too many reviews. I can't handle this. It's too much. It's too much stuff. Okay, so we got here continue. Continue. Okay. Okay, let's remove the checkpoints. Okay, this one is 0 and this one is well. Return count is -3. Okay. Return count is -3. So it has visited the return 3-4 times and then it jumped to a checkpoint. Yeah. Does this make sense? The return count here. Let me think. Return count is return. Return as instruction index reached. Return count, return count, return count. -3, okay. Conditional jump count. Yeah, jump not taken. Jump not taken. Jump taken. What we can also do is we say if not jump taken is set indexer, auto indexer. Okay. we have a debug macro. Debugging. Debug. We have no debug macro. What? We have a release. Okay, we can say if def release and if and if and if and if here. Basically, I would just want to compile that out and release because it seems that we don't need these counts other than for debug purposes. Right. Now, instruction counts. Basically, this is like a wasteful loop here. Okay, so this should fix this counter, return count, jump taken, yeah. Okay. Let's see if that works. Okay, we get a hit here. Conditional jump count 1. Okay. Call stack. Disassemble function named. Is it an early function? ID 1. Okay, well. Conditional jump count. Conditional jump count. Conditional jump count. So what happens if an else branch hits here? Is that possible? Int a equals 0. Put the breakpoint here. Same. Well, let's just put a let's that. Oh, hold on. It also has yeah, let's see what happens if that hits. I'm not sure. Oh man, so many edge cases here. Oh, Jesus. Oh, the loading is so slow. Okay, so we hit this again, and okay, it didn't hit this branch. Interesting. So it basically it means it didn't hit one of the conditional jumps. Is that a problem? I don't know. It is weird, I guess. It's conditional jump. Conditional jump. I think I wonder if it has to put the checkpoint regardless if it has a distance. Because it is here in jump taken. I think we need to. I think we need to remove this else here. Yeah. So that if it would hit here, it keeps on going, and then it checks. Okay, jump not taken. If it hasn't entered this here, then we do jump not taken. That would be set. And then this one, yeah. So basically, if it cannot take this jump because the jump goes outside the function, then we don't take this jump outside. We just keep on going here, there, and then go in here. I don't think that this here would be necessary, but it doesn't hurt to have it, I guess. If checkpoint indices dot empty continue. Jump not taken, jump not taken, continue. Continue. Yeah. Okay, I am a bit worried about this one here. and A equals 0. Yeah. Ah, boy. Downcast. Jump taker. Yeah. Actually, this here makes no sense. Like, a jump has to be taken. So if the jump goes outside, if the jump goes outside, I would imagine that here we would have an assert. No. No. If checkpoint indices is empty, then it should break. It's really hard for me to say if this is correct or not. I would expect that when we leave the whole processing that all these counts are 0. So to me it looks suspicious if one of these is not 0. Yeah. Let's observe a few and see like what these look in general. Oh, it's really tricky. Oh. But I think we are close. The logic looks somewhat reasonable. And it seems to behave also somewhat reasonable, but there's probably some tiny errors here and there. Potentially. Okay. So we have, oh, we actually hit a breakpoint here. Oof. Okay. Oh, that's interesting. That's very interesting. ID, do relay connection manager. To be. Conditions. How is this possible? Is unconditional jump. Is this break wrong? If there is an unconditional jump, I think unconditional jump. We always have to take the jump. We cannot just skip it. Like what we're doing here is invalid. Yeah. If not is set, then yeah, so the Conditional jump. Ah, this sucks. Yeah, this break, it doesn't make sense. We always need to jump this. Yeah. We always need to jump. So I need to say jump taken. Jump taken. Then we take this jump and we continue. Okay. Else. Okay. And so I think here I think what you can do is you can take a copy and put that here, or that sucks. Conditional jump. Can probably take this guy and we move it to the end here. And then we say if not indices empty, then we do this. And then here can do else if, then we remove this, put this here, and then we put this here. And then we take put this here, I think this is correct. And then we remove this here. So if the jump was not yet taken, then we take it here. Condition jump count, yeah. Else, if not empty, then do this, yeah. Continue, and then we always take the jump down here. Unless here, if we cannot take the jump, then we do, then here we break, right? If we cannot, no, hold on, else if checkpoint indices.empty, then we break, else we continue. No. Let's say else actually, this can't hit here. Can this hit? Assert false. I'm not sure. Boy, I don't know, man. Why is it so complicated? Jump not taken. Continue. Yeah. I don't know. I really don't know if that is correct. It's so complicated. I think we will get it. We just need to think really hard about this. Yeah. We just need to think hard. Okay, so it has hit unconditional jump. The jump is not yet taken. It takes a jump. Here, it takes a jump. What happens if it cannot take the jump? Then it will continue down here and will not take the jump. And then it will continue here and do different things depending on if it has checkpoints or not. Yeah. I wonder here at this place when it takes a checkpoint, the problem is it will increment. Oof. Isn't this a problem here? This? If we if we push I, if we push the index where we add, then on the next iteration we will I wonder if there's a problem here. I wonder if we need to push I minus 1 instead. Yeah. Maybe. Or we pop it, we take a top minus 1. I think it needs to be top minus 1. Let's try that again. My gosh. Second thoughts. Second thoughts. It's probably fine. Why is it? Let me see. Yeah, no, I think you could have left the blank line there. Yeah. Man, this logic here is complicated. It really is. Okay, so now it's C. 1, 2. Okay, it's much different now. Oof. C. I wonder if this was correct then. But it should be, right? Because we want to go back to that instruction. ID 9. Okay. That actually means we had a bunch of functions that went through properly. C, 1, 2. Oof. So where did it end then? Let's put a breakpoint here. Break, break. How many instructions? Okay, that's a lot. Break. Okay, this break is fine. 0, 0, 0. Fantastic. Okay, so this looks good. Mm-hmm. 2, 0, 0, 1, 2. Conditional jump. Okay, so sometimes it doesn't take all the code path. Why? Okay, this function is relatively small. Okay. Let's put that into our watch. So this function is really small, but we have 2 jumps that have not been taken here. Let's see. So we have a return at the end. We have a conditional jump here. And another one here. Okay, so we have 2 conditional jumps. It's conditional jump. Okay, so this jumps straight to return. And this as well. Both of these jump straight to the return. Oh. Conditional jump. What is wrong? Both of them jump to the very end. To the last instruction. And then what? Jump to the last instruction. I don't understand how it came to be here in 1. Because we've definitely taken this route here, right? Last instruction reached 2. Huh? How's that possible? Last instruction reached is 2. Huh? How's that possible? Two. This one is conditional jump. Hold on. Ah, it jumps. Oh, I see what the problem is. Right. If we jump, I wonder. I wonder if we should do it differently here. Instead of -1s, we do. So this plus I, that's a problem. How about we do? How about we remove the plus I here? And instead, we add it here to all branches. Plus I. We remove it here. Here we don't do anything. Break. Here we don't do anything. Here we do remove that. Remove that. Yeah. Okay, and then here we do plus I. Here's another one. And here, anything else? Let me see. Continue. Here we have I. Yeah. This looks correct now. Let's see. Man, it's really delicate. This algorithm is delicate. Yeah. Easy pitfalls. I don't think in our conditional jump, I don't think we need this here. We could probably remove that. Maybe. It doesn't hurt, I guess. Yeah. Okay. 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 This looks good. Okay, let's remove this breakpoint. Okay, here we got a C1, 2. Okay, that's not looking too good. Yeah. Okay, it looks like it mostly works now. It mostly works. But there are some cases where it does not. Yeah. Maybe... But maybe these are the cases where... maybe these are just the cases where there's like a jump table at the end, and that's why it thinks there are... yeah, that could be. 5D. 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 Let's see. Instructions. Instructions. Oof. Throw exception. Oh, Jesus Christ. What is going on here? Save codes. So the last instruction reach was 57. This guy is return. Yeah. And so it didn't reach his symbol. Conditional jump count. Who knows? Let's find some other cases. 41, 8, 0. Oof, this one is long. Last instruction. 2, 4D, 2, 4D. 2, 4D. Okay, it's pretty close to the end. Red. Okay, what comes behind it? Yeah. Throw exception. Dead. Error code. It makes it slow. Yeah. Oh, or we hit an infinite loop. That could also be. Yeah. Have we reached an infinite loop? Let's see. So I is 6a. 6a. It's conditional jump. What happens? 6a. Let me put a breakpoint in here. Instruction 70. 7e, 85. 8c, 70. 7e, 85. Okay. It seems like it can't exit this somehow. What function is this? Named function? No. Named function. Copy value. For I max slots. Where's the infinite loop though? For I, that looks pretty safe. That looks also safe. Why is this hanging? Which function ID is it? ID 72. Okay, it's pretty early. It probably just means there's a bug in our logic here somehow. Okay, so let's see. So the jump is taken and this is also taken. It's empty, so it advances. It takes another conditional jump. Also taken. Takes another 8c. And takes another 7. Something is wrong. Something is wrong here. Yeah. But there's no infinite loop here. It looks pretty straightforward. I is only being incremented here. There's no weird logic. No. But actually, oh, hold on. It's being reset here. Okay. Oof, this is expensive here. It does ref counting every time. Oh, shit. Jump taken. Something is wrong here. Why is it jumping? It is jumping up because hold on, it's jumping here, right? I see. I think I understand why this happens. So here we'll jump. And then it never takes the path out. That's why. So what we need to do is if checkpoint is empty, then we need to allow it to escape by randomly taking a jump or not a jump. Randomly or needs to basically we need to jump out to the escape here. Escape by jumping or not jumping. Yeah, because it can be both, right? Checkpoint. Yeah, so like it can be that this was the real escape, right? But this one is not the escape out of this infinite loop. And so if we reach here, then we need to still have the opportunity to take both kinds of jumps. Well, like take the jump or not take the jump here. Yeah. Can we do this that it toggles? It probably needs to be random, right? Random. Oof. Random. How do we do it? How should we implement it? The naive approach would be to just randomize it. Yeah, but maybe that's not the way it should be. Maybe not. Let's think about it next session. Yeah, I will end it here. Yeah. Well, at least we have some pointers as to what to do. Good. I will end it here. I'm really quite tired, so that's good. Yeah. Then I wish you a great day or night. Until next time. Goodbye.